Hello everyone, welcome to my channel Chem Insider. In the previous video we discussed about Grignard reagent and the different types of Grignard reagent it usually undergoes. That is, if you consider for a Grignard reagent, it undergoes three different types of reactions. One is a Zerovantov acid-base reaction, second one being nucleophilic addition reaction, and third one being nucleophilic substitution reaction. In the last class, we discussed about the addition reactions which as Grignard reagent usually undergo. Now, in this class, we will discuss about certain reactions of nucleophilic substitution, where we observe certain process of different product reactant we reacting with Grignard reagent. So let us start. The first one being reaction with ketene. So when you treat Grignard reagent with ketene, what we observe is the alkyl groups which carry a delta negative charge attacks the carbonyl carbon. As a result, there will be shift in the bonded electrons. We get compound like CH2, CH, Cr, single bonded with oxygen, and this is being attached with the magnesium halide. Okay, so this is the normal reaction first which it takes place. Here the oxygen and magnesium bond is in the form of minus and a plus charge. When you treat them with a molecule of water, what we observe is that is a protonated water, H3O plus. So we get H2C, Cr, it has a double bond over here, and a OH. Okay, because of the presence of lone pair of electrons on oxygen, we observe transformation of double bond. That is, we get a compound such as like this, that is R, C double bond O, CH3. So this is how ketenes react with Grignard reagent. So that is, ketene when treated with Grignard reagent, they usually turn out to form a ketone. Next, let us see how this isocyanate molecule reacts with Grignard reagent. It is quite almost the same kind of a reaction. So the alkyl group, let us say R prime, attacks the carbonyl carbon. So therefore we get R, N, double bond C, bonded with R prime, O minus, MgX. So this when treated with protonated water H3O plus, it gives us R, N, double bond C, OH and R. Okay, so now due to the tautomerization of OH group, we observe the lone pair of electrons present in oxygen being converted to keto group. As a result, the nitrogen carries the electrons which then attacks the proton present in the reaction, forming an amine. Okay, so this is now an amide type of reaction. So when you treat isocyanate with Grignard reagent, we get amine. Okay, so now let us discuss about the next set of reaction, that is treating Grignard reagent with carbonates. So when you have carbonate compounds present here, so whenever you have such as a carbonate ester like this OET, so this OET groups are always a better living group. Okay, these are always considered as a better living group. So therefore what we can say is, if the carbonates contain reacting with the Grignard reagent and the Grignard reagents are taken to be in excess, we clearly observe a substitution process of this reaction. So what happens is, Grignard reagent leads to the formation of O minus, MgX and R with OET and OET. So this later forms a keto group because of the migration of negative charge, as it is because this OET group is a better living group. So therefore it forms C double bond O, R, OET. Further, this compound has one more better living group, therefore the same reaction takes place again in order to form a ketone, R, C double bond O, R. So this is how a reaction of carbonates with Grignard reagent can be considered about. Now next, what if we have 3 OET groups being attached to the carbon atom? Then those types of compounds are called ortho esters. But in this case you have to observe carefully. We are not considering the reaction of Grignard reagent with ortho ester, but we are treating them with Lewis acids. That is about the Schlenk equilibrium structure of Grignard reagent. As I said earlier in the previous video itself, Schlenk's equilibrium structure of Grignard reagent is quite very important because of the presence of it being a Lewis acid. Now in this process what we observe is, when you treat Schlenk equilibrium structure of Grignard reagent with our compound, the lone pair of electrons present on the oxygen atom of ortho ester attacks the magnesium compound. As a result we get an intermediate of this shape, OMgX2 ET group attached with oxygen, and the other rest of the compounds similar to that, OET, and a hydrogen. Okay, so this reaction involves in the loss of 2 ethyl molecules at the same time. Okay, so what we can say is the lone pair of electrons present on this neighboring oxygen involves in the transfer of keto in ultratomerization. So therefore we observe this bond being broken down. As a result we can say that we get HC double bond O, which a plus charge, and an ET group, that is a ethyl group, along with OET. Okay, so this reaction later leads to the formation of acetal if they are treated with one more molecule of Grignard reagent. That is, if you treat one more molecule of Grignard reagent, so the same here, instead of treating them with Schlenk equilibrium, we are treating them with Grignard reagent. Okay, so now what happens in this reaction is we get HCOET, OET, and an alkyl group. Okay, so this is how the reaction takes place. So this compound is called an acetal compound. This compound is called an acetal compound. So when you treat ortho esters with the Grignard reagent, what happens is the Grignard reagent turns itself into a Schlenk equilibrium Lewis acid. So therefore the first ortho ester reacts with a Schlenk equilibrium of MgX2 Lewis acid. Then later it is converted to an acetal by treating with one more molecule of Grignard reagent. Next is when you treat them with Weireb amide. So this Weireb amide is a specific type of an amide where we have a keto amide group bonded with nitrogen containing 2 methyl groups. So N dimethyl amide kind of a compound is considered to be as Weireb amide. So here when you treat a Weireb kind of an amide with Grignard reagent, we observe the breaking down of the nitrogen and carbon bond of the carbonyl carbon. So we observe the breakdown of this carbonyl carbon and nitrogen bond leading to the formation of ketone. So we can clearly say that most of the reactions involving amide compounds is clearly giving us a keto group. So in this reaction what we can say is the reaction takes place in order to form RCO R prime with Mg of X being bonded with N dimethyl nitrogen. Okay, so this, if you are treating them this with this compound with a molecule of protonated water, it later forms NH, Me, and Me. Okay, so this is how the reaction of Weireb amide takes place. Now the main important concept of Grignard reagent is, if you are treating Grignard reagent with alpha beta unsaturated carbonyl compound, what we observe is Grignard reagent being a strong reagent or a hard reagent, it usually attacks for the formation of 1,2 addition. Okay, so that is, if you are just using Grignard reagent RMgX, it is a hard reagent, therefore the expected product in this reaction will be because of 1,4 addition. That is, we get OH and R, and we have a double bond as it is without any changes. But if you use Grignard reagent in the presence of copper halide, here cupric halide being a soft reagent carries out the reaction in the form of Michael's addition to give 1,4 addition. So therefore the product in this reaction is OH R. So this reaction may further undergo tautomerization. Okay, this reaction may further undergo tautomerization, or if you treat the reaction with a molecule of water, then the reaction may break down to form a normal compound of double bonded O, keto group. Okay, so this reaction, this is the product if you use Grignard reagent in presence of cuprous solid. If this is the product if you just use the Grignard reagent, that is, so Grignard reagent can undergo both direct addition and Michael's addition depending upon the substrate which you are using. If you are not using anything, then the reaction will be 1,4 addition. If you are using soft reagent like such as a CuX, then the reaction will be supporting Michael's addition of 1,4 addition. Okay, so next is a very important type of reaction which was asked in a previous year question. So here in this particular question they are asking us to react the given reagent substrate with Grignard reagent in a single equivalence. So before starting this reaction, to simplify, first we need to remember a point is the energy of activation required for the reaction to carry out is in the order of acid-base reaction carries out first, so they require less energy of activation, then comes addition reaction, then comes substitution reaction, and then comes elimination reaction. Okay, we have said this, I have discussed this concept in the previous introduction videos itself. Now let us, in this question we have to identify what are the products A, B, C, D, E, R. So first, when you treat this compound of di-keto group with one molecule, one equivalent of RMGX, so the reaction taking place over here will be a type of acid-base reaction, because here we have a OH group which is having an acidic proton. As I said earlier, Grignard reagent is a base, right? So here we have an acid-base condition. The first reaction to takes place is acid-base reaction, because the reaction energy of activation required for this completion of acid-base reaction is less. So therefore we can clearly write down the reaction of first product, that is A, being OMGX. Okay, so this is the first reaction, OMGX being formation. Next is the second step. So during this process what we observe is the loss of alkane RH. Okay, so this is our compound A. Now when you treat one more molecule of Grignard reagent RMGX with the compound A, now here we have a carbonyl group, here we have a carbonyl group with a leaving group. So therefore first it undergoes addition reaction. So now we have to carry out the addition reaction on this carbon, because the addition reaction requires less amount of energy. If you carry out the addition reaction on this carbon, what happens is, because of the presence of a better leaving group, the double bond restores its double bond structure, oxygen restores its double bond structure, as a result leading it to a substitution reaction but not addition reaction. So therefore first we need to add a Grignard reagent across the carbonyl carbon. So the reaction will be XMgO CH2 CrOMgX. Okay, so now this also contains CH2 group, C double bond O, OE2. Now this is our product B. Now when you treat our product B with one more molecule of Grignard reagent, that is RMGX, we get a substitution reaction, that is the alkyl group will attack this carbon. As a result we involve in the shifting of oxygen to form a minus charge. Later the minus charge again forms a double bond. As a result this OET group leaves the substrate. So therefore the compound formed will be XMgO CH2 CrOMgX CH2 C double bond O R. So this is our product C. Now since we have a ketone again, because of the reaction has already obtained the energy required for addition reaction, now if you treat one more molecule of Grignard reagent to this species, we get XMgO MgO CH2 CH2 CrOMgX, one more CH2 CH2 CORRMgX. Okay, so this is our product D. Now once you complete the D product and treat it with a molecule of protonium ion, protonated water, now the complete MgX compounds will be leaving from the reaction. As a result, we get a compound E, that is OH CH2 CH2 CrOH CH2 CH2 Cr twice OH. So this is our product E. So I hope from this particular example we can conclude the reaction kinetics of energy of activation required for acid-base reaction, addition reactions, substitution reaction, and elimination reaction. So now this brings an end towards our study of Grignard reagent and the different types of reactions which a Grignard reagent catalyzes or carries out, right? So I hope you have understood all these concepts. If you do have understood these concepts, please do subscribe to my channel and share this video among your friends so that you can get updates about the videos which I'm going to post about more about the reagent and the concepts which are required for NET, GATE or state eligibility test exams. Okay, thank you for watching.